So this quick lecture, quick video is really an opportunity to test your knowledge if you understand these equations. So you should have hopefully already watched the previous video that went through these equations in terms of the amount of safety stock needed when you have decentralized versus centralized storage policies. And so as a reminder, this equation and these slides you've seen, but just as a reminder, the impact of spatial centralization, what that means is instead of having K separate locations, we're going to have one single location where we're going to have all the inventory stockpiled. And we're going to fulfill the demand from all those K regions in that single location. And so what's the impact of that from safety stock? And if you remember from last time, the key difference here is that the standard deviation of lead time demand goes down when we aggregate or when we pool multiple demand locations. And the insight there is if you have one region that goes up and one goes down, we get to cancel them out, which doesn't get to happen if they're all operating independently. And so these equations you use to get the safety stock, and you'll use this a lot to do the problem, the book problem about the Toyota dealer. You'll use these equations a lot. And so I wanted to go over them and try to give you some intuition about what's going on and do some clicker type questions to get some intuition. Okay. All right, so my first clicker question for you is, what is the standard deviation of weekly demand if region 1 and region 2 pool the demand into a single location? Okay. And so just to give you a little background, region 1 has a mean of 100 units per week and a standard deviation of 25 per week. Region 2 also has a mean of 100 per week and a standard deviation of 25 per week. And both of them have normally distributed demand. And we should assume that their demand in region 1 is independent of the demand in region 2. And so I'd like you to think a little bit, pause this video if you need to. Do you think the answer is A, B, or C? All right, so hopefully you've thought through this, you paused the video a little bit. The correct answer here is A. And the reason it's A is we can use the square root rule because our two regions are independent and they're identically distributed. So they're both normally distributed with the same mean and standard deviation. And so we can use the special equation, which is the equation of the square root of K times the standard deviation of weekly demand. And so we have 2, K is 2 because we have 2 regions, so square root of 2, and then per week is 25 per week. And so the correct answer is A. Square root of 2 times 25 would give you the standard deviation of weekly demand for both of these regions pooled together. Hopefully that makes sense. If not, I'd encourage you to go back to the previous video, watch that, as well as send me emails or questions and attend office hours. All right, so the next question here asks, what is the standard deviation of lead time demand if region 1 and region 2 pooled their demand into a single location and lead time is exactly 3 weeks? So the information in terms of the demand per week is the same. So region 1 and region 2 both have normally distributed weekly demand with a mean of 100 and a standard deviation of 25. And you can assume they're independent regions. However, we're not asked for weekly standard deviation. Now I'm asking you for the lead time standard deviation. So please pause the video, think about this. Is it A, B, or C? So the correct answer here is again A, and the idea here is you have to do 2 steps. So you could think about from the previous slide 21's correct answer was square root of 2 times 25. That aggregated things spatially, meaning it aggregated region 1 and region 2's demand into a central regional or central location. So that's a spatial aggregation. But that was only the weekly side. Now we also need to convert this to a lead time. And so as a reminder, the lead time is 3 weeks. And so that is something, the square root of L times our standard deviation of weekly demand, but now the weekly demand is centralized. And so A is the correct answer. And I have one more for you, and here the demand information has changed. So my question to you is, what is the standard deviation of weekly demand if region 1 and 2 are pooled together? Here, region 1 has a mean of 100 per week and a standard deviation of 25 per week, but region 2 has a mean of 200 per week and a standard deviation of 4 per week. Again, we can assume that the demand in each of these regions are independent of each other. So what do you think? What is the answer to this question? Is it A, B, or C? Pause if you need to think about this problem. So the correct answer here is C. C is the correct answer because the key thing here is we do not have IID. We have that they're independent, but they aren't identically distributed. That's because while they're both normally distributed, they don't have the same mean and standard deviation. So we are no longer able to use the simple equation that was given, and instead we need to use the variance equation. So remember, you need to work in the variance space, and so you need to take 25 squared is the variance of the first, plus 4 squared is the variance of the second. That would give you the variance of the two weekly. This 2 times the sum of whatever goes away because rho is 0. And so we would have 25 squared plus 4 squared is the variance of weekly demand pooled together. And then the standard deviation would be the square root of that. So the correct answer to this problem is C. Thank you.